This is section 11.4, the fundamentals of probability. So finally, we're going to start using all of the counting methods we've talked about in the first three sections to actually calculate probabilities. Okay, so we need some definitions first. Any occurrence for which the outcome is uncertain is called an experiment. Now, the experiment might be flipping a coin, tossing dice, making free throws, whatever it is, okay? The set of all possible outcomes of an experiment is called the sample space of the experiment, denoted U, okay? An event, denoted E, is any subset of a sample space. So, for example, if we had a fair coin, which means that it's equally likely to land on heads or tails, okay? This is an example of an experiment. In this case, our sample space involved is either heads or tails. Okay, that lists all the possibilities for flipping a coin once. A possible event for this experiment would be E equal T. So that's a subset of that. Okay, now there are two kinds of probability we're going to be talking about. We have theoretical probability, which is what we're going to start, and then empirical probability. Okay, theoretical probability applies to situations in which the sample space only contains equally likely outcomes and all of them are known. Okay, so there's no possibility of an outcome we haven't thought about yet. So how do we compute the theoretical probability? Okay, if an event E has n equal to E, or n of E equally likely outcomes, and its sample space S has the n of S equally likely outcomes, then the theoretical probability of event E, denoted by P of E, is the number of outcomes in event E, the number of ways we can have E happen, over the total numbers of possible outcomes for our experiment. Okay, we're going to be working a lot of examples with this, so if it's not perfectly clear yet, don't worry about that. Okay, now one thing you want to be aware of is our probabilities are going to be a number between 0 and 1. The sum of all of the probabilities of all the possible outcomes is 1. So if something can never happen, its probability is 0. If something will always happen, its probability is 1. Most of the time, we're somewhere in between, and if we add up all the different probabilities, we should get 1. Okay. Now, one thing we do need to talk about is a lot of the problems that we work are about playing cards. So just in case you don't know this, there are 52 cards in a standard deck. There are 13 cards in each suit. Okay. There are 2 red suits, which are hearts and diamonds, and 2 black suits, which are clubs and spades. Each suit contains the cards ace through king. Okay. Ace in this book is low. And this is something I have not heard anywhere other than in this book, but they call Jack, Queen, and King picture cards. I've heard face cards, but I've never heard picture cards, but that's what they mean. Okay? So, with that in mind, let's look at some problems. Okay? So, let's say our experiment is that we're rolling a die. The set of equally likely outcomes is 1, 2, 3, 4, 5, 6. So we roll a dice, we're going to get one of those 6 answers. Find the probability, each probability of rolling whatever, okay? Well, how many outcomes do I have here? I have 6 possible outcomes. So this probability of rolling a 5 is what we're asked for. Is going to be something over 6 because there are 6 different ways to get to roll a die, 6 outcomes. How many different ways can we roll a 1? Only one way. So this probability is going to be 1 over 6. Okay. a number greater than 4. Okay, so the probability of a number greater than 4 would be, there are 6 possible rolls, so it's over 6. How many different numbers are greater than 4? 5 and 6. So there are 2 ways we can do that. Now you're always going to be asked to reduce any fraction. So this probability would be 1/3. Okay. Find the probability that we roll a number less than 8. Okay, well, we know there are 6 possible outcomes, and we want to roll a number less than 8. Well, how many options do I have? 6. And 6 divided by 6 is 1. Now, like I said earlier, if something is always going to happen, its probability is 1. There are no numbers 8 or larger on this particular dice, so we're always going to roll something less than an 8. Okay, now related, what's the probability that we roll a number greater than 8? Okay, well, there are 6 possible outcomes. And how many options do we have greater than 8? None of them. 0 over 6 is just 0. So here, this will always happen, so it has a probability of 1. This will never happen, so we have a probability of 0.